Hey guys, this lesson is about solving equations that involve logarithms. Alright, we've been working on exponential equations and turning them into logarithms, but now we're starting with logarithms and trying to solve equations that look like this. Now, as always, put your pencil down. Watch me do the example and then do it yourself. Put your pencil down while you're watching the video. You know better. I'm not playing. For the first few problems, we're going to be using this one-to-one property of logarithms, and the phrase easy peasy lemon squeezy comes to mind. I mean, look at this. If the logs are the same, okay, check this out. We have log base b, log base b. If that part is the same, then that means the other part must be the same. X must equal y. That's the one-to-one property of logarithms. So looking at problem number 1, we have log base 4, log base 4. If that part is the same, then that means this part must be the same. Okay, so x plus 3 must equal 8x plus 17. And then we will solve this like normal. So, let's see. We will subtract 3. No, sorry. We have x's on both sides. Let's get those together by subtracting x from both sides. So that's going to give me 3 is equal to 7x plus 17. Then I would subtract 17 from both sides. So that'll give me 7x is equal to negative 14. Got to get x by itself, so let's just divide by 7 on both sides. So that tells us that x is equal to negative 2. Now, for the record, you can't have the log of a negative number. Like, for example, log base 4 of, let's say, let me make something that would kind of make sense. Let's say negative 16. Watch what happens if we put this in our calculator. Let's see. Decided to use the graphing calculator so I don't have to use the change of base formula. Okay, so log base, yeah. Oh, look at that. The calculator does it just fine. So log base 4 of negative 16, for example. Bam. Oh, error. Non-real answer. Oh, quit. Oh, error alert. Here's why this does not work. Remember, this means 4 to the what power is equal to negative 16. Now look, 4 here is a positive number. Is there any way that I'm going to have some exponent that's going to suddenly turn that into a negative number? No. Even if I do, like, say, a negative 2, for example. Because maybe you're thinking, well, what about a negative 2, Mr. Burton? Will that work? No. Negative 2 does not make it a negative 16. Negative 2 just drops you down to the denominator and makes you 1 over 16, not negative 16. There's no power that's going to turn this into a negative number. So this is impossible. So if I had this type of a situation, I would have to say no solution. Alright? So maybe you're thinking, oh, well, I guess he's talking about this. Because we got this negative number, it must be this no solution thing he's talking about. No. Negative 2 is okay. The reason why, we don't have the log of negative 2. One of the things we have is the log of x plus 3. If x is negative 2, then I have the log of negative 2 plus 3. Alright? Is this okay? Well, let's see. This is the log of 1. Log base 4 of 1. This is a positive number, so it's okay. If this made a negative number, that's when it would be no solution. Okay, let's look at the other one. The other one we have is log base 4 of 8x plus 17. Again, if x is negative 2, then this becomes log base 4 of 8 times negative 2 plus 17. Well, 8 times negative 2 is negative 16. So that's negative 16 plus 17. Is this a negative number? No. Negative 16 and positive 17 is a positive 1, which is okay. So this is just fine. The moral of the story is you have to check your answers. You have to make sure you're not getting a negative value inside the parentheses. Alright? Because if you do, the thing that looks like an answer is what you would call extraneous. And you will write no solution. So watch out for extraneous solutions. You have to check your answers. Anyway, this is taking too long. Looking at number 2. Pencils down. Alright, I'm serious. I see you. You're not slick. The log part is the same, so that means this part must be the same. Okay, so 2x plus 3 must equal 5x minus 6. Subtract 2x from both sides. So that'll give me 3 is equal to 3x minus 6. Go ahead and add 6 to both sides. So I get 9 is equal to 3x. Divide both sides by 3. And I get x equals 3. Now this is probably the answer, but take a peek and make sure it's not going to give you a negative result. 2 times 3 is 6, plus 3 is 9, that's okay. 5 times 3 is 15, minus 6 is 9, so that's okay. Alright, number 3. Okay, 2x minus 1. So, again, the log part is the same, so that means the 2x minus 1 must equal x plus 5. Easy peasy lemon squeezy. Anytime you have x's on both sides, take care of that first. So, subtract x from both sides. That'll leave me x minus 1 equals 5. Add 1 to both sides. I'm going to get x equals 6. Alright, make sure it works. If I plugged in 6 right here, I would have 2 times 6 is 12, minus 1 is 11. If I plug in 6 right here, 6 plus 5 is 11. So 11, 11. So that's okay. Always check your answers. Number 4, x plus 3 must equal 3x plus 1. Yeah, let's get these x's together. So subtract x from both sides. That's going to leave me with 3 is equal to 2x plus 1. Then subtract 1 from both sides. So I've got 2 is equal to 2x. Now divide by 2 on both sides. Oh. So that's going to give me x equals 1. Alright, check and make sure it works. If I put 1 here, then this will be 4. If I put 1 here, 3 times 1 is 3, plus 1 is 4. So that's okay. Alright, they should be the same, but they can't be negative. Alright, that's it for the front page. Alright, please make sure you do not have a pencil in your hand. Alright, now, that's what you do when you have like the same log on both sides of the equation. Now on the back page here, we only have one log term, alright? Log only on one side. you can probably guess what I'm going to do. When we had problems and we started off in exponent form, we usually had to rewrite it in log form. So guess what? If I have a problem here that's in log form, guess what? We're going to wind up rewriting this in exponent form. Start with the base. Alright, now in exponent form, the base, just bring that down. 4. Bam. Okay, now the rest of it. Obviously, in exponent form, there won't be any log, so forget about that. These two parts have to change sides of the equation. Now remember, this is exponent form, so this 2 is going to come over here, but it's going to be the exponent. The x plus 3 is going to come over here. And we're solving for x, but it's easy because 4 squared is 16. So 16 is equal to x plus 3. Subtract 3 from both sides. So that's going to give me 13. X is equal to 13. Again, make sure I'm not getting a negative number here. So 13 plus 3 is 16, so that's okay. Alright, how do I write this in exponent form, you guys? What's the base? Yeah, this is invisible base 10. So when we rewrite this in log form, when we write this in exponent form, there will be no log. So I'm going to start with this base of 10 and bring that down. Okay, now these two things have to change sides. So this would be like 10 to the 1 power is equal to 3x plus 1. Okay, so you know that 10 to the 1 power is just 10. Subtracting 1 from both sides, that'll give me 9 is equal to 3x. And then dividing by 3, it gives me x equals 3. Alright, if I plug it in, 3 times 3 is 9, plus 1 is 10, so that's okay. Can't be negative in there. Alright, number 7. Pencils down, please. Start with the base. The base here is 4, so bring that down. There will be no log in the rewrite. These two will trade sides. So this is going to come over here and become an exponent. The x plus 3 is going to go over there. And isn't this the exact same problem we just did? Okay, why? Guys, I did not write this worksheet. I'm just saying. I'm grateful to whoever wrote it, but that's clearly the exact same problem. So, oopsies. Moving on. So number 8. All right, it was already the shortest assignment ever. Just got a little shorter. The base. All right, in exponent form, there will be no log. Bring the 5 down. Boom. These two things are going to change sides. The 2 will become an exponent. And on the right-hand side, I'll have 6x plus 1. 5 squared is 25. So 25 is equal to 6x plus 1. Okay, subtract 1. So I've got 24 is equal to 6x. Clearly, it's time to divide both sides by 6. So that will give me x equals 4. Okay. 6 times 4 is 24, plus 1 is 25, so that's fine. So all of these ones had a solution. So that's it for this lesson. Go get your homework assignment. I'll see you on the next video.